Hey girls. So this presentation is basically so you understand what is a hypothesis and that you have clear why are we writing hypotheses like we've been writing hypotheses all year long, meaning the structure if, then, and because. So just keep in mind that everything is connected. So the more connections you make means that you're going to understand why are we doing it, and it's going to be easier for you to perform at the end. So a hypothesis. A hypothesis is a tentative answer to a well-framed question or situation, which basically means an explanation on trial. Always remember, hypotheses are explanations that you can actually test. Now, the reason why we ask you for the structure, the if, then, and because, is because they represent something. And I'm going to explain each one of those parts of the structure so you are able to make the connection between the if, then, and because to things that you've already done. Because once you're going to write the hypothesis, you're going to connect everything that we've been building in the last classes. So they represent something, and it's important to have it clear that they just represent something. What is the if? The if represents a situation. And a situation is something that you can observe, that it is outlined, and that it is specific. So if you would want to find a keyword for this, it would mean measurable. Situations are something that you can measure. So if you have something that you can measure and you can observe, and it is outlined and it is specific, it means basically that we're talking about a context. This is exactly why we ask you to write down the introduction, because we needed you to be able to narrow things down into what's going on. When you were talking about the pandemic, are you talking about what's going on in Colombia, the world? Are you talking about the world right now as the pandemic, the economic situation? So it's really important that you understand that the if is trying and is going to make you think about something specific and a context that is clear and focused. Which leads us to the second part, and is the then. The then represents a prediction, and clearly a prediction that is based from a situation, and just like we've been working, is something that comes from your curiosity and your questions regarding that context. So the prediction basically is just what you expect. And if you want to understand what is a prediction, it has to deal with these words, and it is something that is possible, that is viable, and that is probable. And all of those ideas are because you have already some information that makes you think, yes, it can happen, or okay, it's not likely to happen. This is why, based on that idea or that knowledge that you already have, that prediction has to be able to be measurable. And this is why we ask you to graph the predictions, because anything that you can measure, you can actually graph. This means that the prediction is an outcome that you can measure and that is based on what you think is probable or possible from a given context. And if you want to think about it, is what do you expect? What do you expect of a given situation, which means of what's going on. Now, this is really interesting because, and this is basically how we're going to look at it, the if, you actually state what you can measure, but the things that you're not asking about. This is why you are actually talking about the independent variables. You're not talking about the things that you want to look for, but things that you know that happen. For example, time. For example, the presence of coronavirus. In the prediction, when you actually write down the then, you are stating what is the dependent variable, the one that you think has a connection with the situation. So keep that in mind, because when we read the predictions if, then, because, it is really easy to know what are the variables that you're talking about, because you actually have to state them in that structure. Which leads us to the final part. The because in the structure is the one to represent the hypothesis, meaning that at the end, when we ask you for a hypothesis with the if, then, because, it's not because all of it is the hypothesis. It's because it's going to be easier for you while you write it to understand exactly what part is going to be your hypothesis, which is the because. And a hypothesis, since it's an explanation, it depends on knowledge, on information, ideas, and concepts. Your ability to explain a prediction of a given situation is based on these aspects, which is what leads you to be able to explain it. And it's going to be interesting because I know that we had some issues using this word, but your ability to explain, it's based on how much you know, how much the ideas that you have and the concepts that you have. And if you think about it, that is called a theoretical framework. Your ability to explain something depends on what is your theoretical framework. It meaning that if you know ideas regarding physics, it's because you have a theoretical framework on physics, which allows you to explain whatever prediction you came up. So the hypothesis is only the because in the structure and actually represents the why do you expect that to happen? What a prediction. And the last thing to have in mind is that in order for you to be able to explain, you have to, again, build that theoretical framework, build that knowledge, and that knowledge is built based on the context and at the same time of the outcome. This is why we made you, in the introduction, learn a bit about viruses, because you needed to make bigger your theoretical framework in terms of how much I know regarding viruses and pandemics. If you have all the components and you're able to provide a clear hypothesis to your prediction, then you have the rest of an experimental design. Everything that you look right now, you're going to see that it's going to appear in the experimental design. So this is why we ask you to build hypotheses like this. So it's really clear for you everything that you're going to need later. Which leads us to the next part, and is how to avoid making only predictions. For this, I'm going to give you 3 examples, and just look in the slide how from the statement, it's really easy to understand what are the variables, what is the context, and if there is or not an explanation. So this is from an example of people that were thinking they were making hypotheses, but at the end they were making only predictions. So let's analyze it. What is the situation? If a plant receives fertilizers, can you observe that it is outlined, is it specific? Yes, which means the context is okay, and we know that it is the use of fertilizers in plants. Now the prediction. It will grow to be bigger than a plant that doesn't receive fertilizer, meaning that you assume that receiving fertilizer is going to make things grow. Now, it is not an explanation, it's only a prediction. This is why this is an example of a prediction rather than a hypothesis. Does that prediction is possible, viable, and probable? Yes. Why? Because it has in mind some information. That is the one that is lacking. It doesn't explain that information as how do you came up with this prediction. Now just look that from the then argument, you can immediately know what are going to be the variables. So if you would have to imagine a graph, it would have to be regarding the plant's growth and the amount of fertilizer, which would be the outcome. So this is not a hypothesis. How do you change this into a hypothesis? Well, you need to provide the explanation. And how it works is basically thinking, how do I connect the situation with my prediction? How do I explain that fertilizers make plants grow more? It's because I'm able to give a connection between the independent variable and the dependent variable. So what is the connection between fertilizer and growth? Nutrients. So I know that nutrients provide growth. How do I know this? And this is really important, girls, that you look what I'm going to do right now. How do I know that nutrients provide growth? Well, basically, it's because from what I know, the concepts that I know, my ideas, information, knowledge, makes me be able to say, oh, it's because nutrients provide growth. I am capable of explaining, making the connection of cause-effect between nutrients and growth. Because nutrients are biomolecules, and all the 5 types of biomolecules that we talked about, they provide something essential if you want to increase the number of cells, which is basically growth. When you grow, means that you have more cells than before. I'm not going to explain it, but it's just to show you this diagram represents what it would be my explanation. If I would have to translate the diagram into a paragraph, it would be me explaining how nutrients produce growth. And this is basically what you're going to have to do. So you're going to have to use your ideas, the concepts that you have, and information to be able to come up with a plausible explanation. So if you add this into the prediction that we had before, then you have a really solid hypothesis. If a plant receives fertilizer, then it will grow to be bigger than a plant that doesn't receive fertilizer, because fertilizers provide more nutrients than normal soil. This is what you're going to have to do at the end of the class, and this is what you should do every single time you are faced with coming with a hypothesis, which you cannot have if you don't have a clear context and you already have in your mind a possible outcome. I'm just going to give you 2 more examples of hypotheses that are not hypotheses and how they would look with real hypotheses. Example number 1, if food is present in the aquarium, then snails will move with greater speed towards the food. No explanation whatsoever, so how could we add an explanation, or what could be a plausible explanation? Because snails compete for food. When you use the word compete, you are being specifically that you know that it is a behavior and that there are going to be differences in each behavior. Example number 3, if the farmer burns the prairie, then the next year will produce taller plants in his field than the previous year. No explanation. What is the connection between burning the prairie and having taller plants? The fire fills something up again, nutrients in the soil. And we already know the connection between nutrients and growth. With that in mind, remember to give an explanation, and just so you know, it's all based on how much you know, and it doesn't mean that you have to go and read right now, but it makes about how much you know or ideas and how much you can connect those. So if you have any questions, just let us know, and thank you for watching.